and we will get started with the content in just a minute. Hello, everyone. My name is Josh McGilliland. I'm the chair of the Sea Scout Marketing Committee. This is our first webinar for 2021, focusing on able piloting. We are live on Zoom, Facebook Live, and YouTube. Thank you all who have joined us tonight on any of our streaming platforms. Our presenter this evening is Doug Love, who's a Vice Commodore in the Golden Gate Area Council. And I will now turn it over to Mr. Love. Doug? Take it away.
Great. Thanks, Josh. So ladies and gentlemen, thank you for joining this webinar. I hope you'll find it interesting. Tonight's purpose is not necessarily to teach somebody enough to pass off the requirement, but to make them familiar enough that they feel comfortable in going in and taking care of the requirement when we're able to get back on the water. So with that, I want to get started. So able requirement number 10, piloting. Piloting is always a problem for our youth. Part of it has to do with the fact that, a number of ships out there, especially new ships, haven't had much experience with piloting, and I hope this helps. So to begin, there are 7 sections talking on Able 10. First one is how to keep a ship's log. The second one is how to plot a course and follow it using dead reckoning. The third one is finding and plotting your position. The fourth one is setting danger angles. Then there's a little bit about GPS navigation, the advantages of using radar under navigation, and then a bit about various publications that a navigator should be aware of and how to use them. So without too much, I want to go into part A first. And these are the requirements. You have to be able to describe a deck log. You have to keep an accurate log for 3 4-hour watches, or at least 3 cruises. So 3-day cruises, for instance, would work. And for pedal-crafted scuba, the scout must be able to keep a journal or log of at least 3 dives or trips, including locations, time of entry and exit into the water, water conditions, dive depths, participants in notable events. Now, the materials you really need for this are blue and black pens, and you have to have a bound journal, with the exception of dive logs. Dive logs can be 3-ring, but normally a log is kept in a bound journal with sequentially numbered pages. And I'll go into why that is in just a minute. So ship's log is a legal document. It's the primary source of information concerning a ship's voyages. All entries have to be written legibly in blue or black ink. There's a mistake, you have to cross it out with a single line and initial it. All log entries have to have the time of when the event happens. At the end of a watch or at the end of a cruise, the log is typically signed by the person filling out the log or the person who secures the log for your vessel. A log for a ship is to be kept on board the vessel until such time as it's replaced with a new log, at which point it still is maintained with the vessel. And it may be put somewhere else into storage, but it has to be in possession of the Sea Scout ship. So these are actually not all of them, but some of the requirements for a log according to the operations manual for the United States Navy and Coast Guard. You have to have a list on board unless you have a separate manifest. You have to list your preparations to get underway, the time major ship's equipment is brought online or taken offline, the time and duration of your safety drills, any significant occurrences during the voyage, the time the vessel got underway or was anchored or was moored, the time of any ceremonies and their nature, if you have any. For instance, on my ship, we have done, for instance, burials at sea in the past, and those have been duly logged in our logbook. Major navigational data, including course changes, speed changes, dead reckoning positions, all that kind of stuff, and the arrival and departure of ship's personnel. So for instance, if you're on a cruise and somebody has to leave and go home, you have to log them out because they've been logged in. So that way you make sure you come home with at least the same number of people you left with. So this is an example of a ship's log. And as you can see, this is just a simple little cruise, lasted a couple of hours, where you have a fictitious Sea Scout ship, where they've logged that they're making preparations to get underway, and they've listed the weather, where they've listed the time that their main engine was fired, and SSG stands for Ship Service Generator. So this happens to be a power vessel that has its own generator, that they got underway, that they passed a marker at a certain time, that they took a GPS fix, altered their course, returned back to their original course and speed, continued on their way. They arrived at an anchorage, and they anchored in so many feet of water with how much anchor rod they have out. In this case, I said 2 shots of chain because they were anchoring in 18 feet of water, keeping a 10-to-1 ratio kind of thing. Then they had lunch. They had lunch secured. They did a man overboard drill. And then they launched their small boat for Liberty, and they set an anchor watch. Okay, so to answer your question about who's responsible for doing a log, it is the person who is doing the navigation duties who does a log. And if you have, you assign a person to do the ship's log. If you're out there and you're doing a Sea Scout training thing on more than, say, a small 2-person sailboat, you should have a ship's log. And that's because should something happen, you have to have a record of what happened. And I hope that answers your question. Okay. So you can see here, you know, and I made this up. This is the Sea Scout Ship Enterprise, and it was signed by, you know, Pavel Chekhov, who was the navigator on the Enterprise. Okay, great. I'm glad I could answer that for you. Okay, that's fantastic. So with that, moving on to the next slide, if I can. Okay, so if you're a scuba ship, you have to, and you're a scuba diver, you guys already know this, you have to keep a dive log, right? That includes the date, time, and location of the dive, the profile of the dive, including your maximum depth, and your surface interval and your bottom time, the equipment you used, your dive and weather conditions. You can include a photo log. You can include various encounters with various, what they call nature encounters, so various fish and aquatic sea life and corals and all that kind of stuff, and a rough map or comments. And so this is a sample dive log page, and I've also included the source for this dive log page. Hang on to that question. We're going to get there in just a minute when I get to the fixing your position part, okay? So for paddlecraft and whitewater logs. Now, this is a little bit different, and it's because generally you don't have enough room on a paddlecraft to have somebody sitting off to the side logging everything, right? So what you're going to keep is a journal, and you're going to keep a journal of the number of your participants, the location, the date, the body of the water that you're paddling on, the time that you've passed significant landmarks along the river or lake that you're paddling on, the time and location of stops for rests or meals, the time and location of stops for overnight camping, if there are any, approximate time and locations of significant hazards. Now, that becomes important because later on, if you want to paddle the same body of water again, you have a record of where some of those hazards are, right? For whitewater, you should include the class of rapids that you navigated, either estimated or known, the approximate distance covered each day, and any other events of note. Okay, so here we go. Here's where I'm going to start answering your question about position. So, plotting a course, okay? So in order to plot a course, you have to, for a normal traditional Sea Scout vessel, you have to plot a course of a minimum of 3 legs and execute it doing dead reckoning. And if you looked at the able webinar or the ordinary webinar, there's all sorts of rules about when you do dead reckoning, okay? For scuba, you have to make a dive of 3 legs and navigate it using a compass, keeping track of times and distances, okay? And logging all of that into a dive log when you get back and done. And you can plan ahead using a chart ahead of time, including the depth and projected depths and topography that you're going to be going under or going to diving at. And then finally, for paddlecraft and whitewater, you plan a trip on a local body of water, including your estimated time of departure, your estimated distances, compass directions, estimated time to stopping points, and times of arrival. And for some bodies of water, actually most that you're going to be doing paddlecraft and whitewater on, you're not going to have navigational charts. You're going to have topographical maps, but the process is still the same. Now, so these are some of the materials you're going to need. Obviously, you're going to need, pencils, erasers, parallel rules, triangles or a plotter, dividers to measure distances, a nautical slide ruler, a calculator, Okay, and I'll explain what a dead reckoning table is in a minute. If you're on a ship, on a vessel that has a compass with deviation table, you're going to need that, and some kind of accurate timekeeping device, right? A stopwatch, a watch with a stopwatch function, something where you can keep actual time. So this is a dead reckoning table, and this is the one I use all the time. And the way it's set up is I start off with a time of my starting the voyage, and the latitude and the longitude would be where I'm starting from. Then I plot a true course to where I want to go, and I correct it to ship's compass. I put in an estimated speed, and I put in a distance, and then I put in an ETA. Then I take the ETA over here and I drop it into the second one. And that becomes, now I'm at this point where I said I was going to be, and I'm going to go to my third leg and my fourth point and my fifth point, my sixth point. And this makes it very easy for a couple of things. For instance, should a chart accidentally get ripped, torn, erased, coffee spilled on it, that kind of thing, you can go back and you already have an additional record of all your courses and stuff that you can refer back to as the navigator. It also makes it very easy to recreate a voyage once you're done on a chart, so you can see how well you did. Okay. Yes, as a matter of fact, it is. It is exactly like that. And I don't necessarily name the routes, or actually when I do electronic navigation on my vessel, we have set routes we name. And that's because I'm in the San Francisco Bay and we have very, very strict navigation and vessel traffic service rules. So we have certain fixed routes that we have on file that I can call up. Okay. So does that answer your question? Next one. So in order to pass this requirement, right, your plotted courses should be accurate to within 1 degree, and they should be measured with 1/10 of a nautical mile. Estimated times should be accurate to plus or minus 5 minutes. For scuba, paddlecraft, and whitewater, there may be additional variations due to dive conditions or river conditions. And though that the amount of variation should be discussed between you, the scout, and the adult leader who's going to sign you off in advance. So for instance, I did a paddlecraft trip and everything was within 2/10 of a nautical, or 2/10 of a statute mile. And it was like plus or minus 15 minutes. And that's because you don't know necessarily exactly how fast the river's flowing and that kind of thing. Next one, position determination. This is where I want to talk about how do you find your position, right? And somebody asked about GPS position. So you have to do each of these methods: bearings from 2 or more known objects, by a running fix, and by establishing an estimated position, which is a special little class of its own. It's not really a fix. So let's talk. These are the materials, again, you need, and it's pretty much the same charting materials you're going to see throughout this. Okay. You need some scratch paper to work out some calculations and that kind of thing. But here's what I want to get to. So there are 4 types of plots, basically, in order of accuracy from the least accurate to the most accurate. The least accurate is a deduced reckoning or dead reckoning position based solely on time, speed, and direction. So we are going on, X course for X number of minutes at X speed, we should be here. An estimated position is based on a bearing or line of position to one known object. And I'll show you an example of that in a minute. A running fix is where you take a bearing on a known object, You're going along a course for a period of time. You take another bearing on the same object, and then there's a little trick where you move your first bearing line to meet your second bearing line, and that becomes called your running fix. And it is fairly accurate. And then finally, a fix is where you have at least two bearings on two different positions, or two objects that are already known and charted. So let's talk about these for a minute. So methods of taking bearings: electronic, like by radar, or visual by hand bearing compass or Polaris. And the most common method is by using a hand bearing compass, but there's a couple of things I need to talk to you guys about when you do this. Okay. And we'll get to that in a second. So when you're using a handheld bearing compass, you simply sight the object and get the magnetic bearing off the dial of the compass, and you note the time. If you can see two or more objects, you can plot a fix. Okay. In order to plot a fix, the magnetic bearings must be converted to true bearings by either adding or subtracting your variation. If it's easterly, you would add it. If it's westerly, you would subtract it. And here's the key: you ignore deviation, because a deviation table is only set up for the ship's primary compass. It's not set up for any of the bearing compasses or anything. So you don't know what the deviation is ever when you use a handheld bearing compass. So you ignore it. The true bearings are then plotted on the chart, where they become known as lines of positions. We call them LOPs. And where they meet is where you are, because where two lines meet, by definition, that's the mathematical definition of a point. Okay. Now, a Polaris is a special kind of device that contains an entire compass card. There's an example there. They're used on larger vessel, and they're used to take relative bearings relative to the course the vessel is traveling on. So to convert relative bearings to a true bearings, you have to go through the following steps, right? You have to add the relative bearing to your course if you're doing relative bearings. If the result is greater than 360, you have to subtract 360, because there's only 360 degrees in a circle. Then if you're steering by your magnetic compass, you have to apply your compass corrections. And then the result is the true bearing, which can be plotted on the chart, right? And this is an example, right? So you've got a ship going this way. There's the relative bearing. Okay. So they're actually headed kind of, east, south, southeast, and they get this relative bearing to this vessel. They add and subtract, and it all comes out to the true bearing to that vessel, for instance. Now, so here's an example I gave you. So you're steering a course of 245 degrees per your ship's compass. Your variation is 13 degrees east. Your deviation is 1 degree west. You sight a lighthouse at 133 degrees relative. So what's the true bearing of the lighthouse? So you go through, you add the compass course to your relative bearing. You subtract, and it's over 360. So you subtract 360, and you get 18 degrees as your bearing. And because you're on a ship's compass course, then you have to apply your corrections. So you would subtract your 1 minute of deviation, and then you would add your 13 degrees of easterly variation. So the lighthouse would actually be at 30 degrees true. So why do we do this? Because, again, wherever you have two charted known objects, and you can get a bearing to them, wherever they meet, that's where you are. Okay. And this would be an example, again, shown actually on a chart this time, of a properly labeled fix. So they've taken a fix at 0459, and it shows this one light up here at 067 degrees true. They took another bearing a minute later at 0500, and it's at 168 degrees true. Where those two lines cross, that's where the vessel is at that time. Okay, and then you would label the fix with the latest of the two times. So you would say 0500 fix. Okay, and then you can get your latitude and longitude because you now have a point where you are on the chart. Now, sometimes you'll do a 3-point fix where you have 3 objects. Now, the problem with those is they never, ever quite come out true to a single point. And the reason is the time difference between you taking, a bearing to this island, a bearing to the lighthouse, a bearing to that jetty. And by the time you plot them all, you end up with a little triangle that we call a cocked hat. When that happens, don't freak out. What you have to do is you assume you are in the center of that triangle. And the smaller you can make the triangle, the better. Okay? So a cocked hat is not necessarily a mistake. It just happens because you're on a vessel moving through the water. When you plot a line of position, it should always be labeled with the time and the true bearing, like this: time on top, bearing on the bottom. That's standard practice throughout the maritime industry. Pretty much every single maritime military service does it this way. And that's so that anybody else looking at your chart work can see, oh, at 1300, they took this line of position and it was 045 degrees. Got it. Perfect. Thank you. Okay. So I'm going to talk about a running fix. So a running fix is where you're going along a course and you see a lighthouse, and this is a lighthouse. And you take a bearing, and at this point, it's like 90 degrees true. And then you travel along for a certain amount of time and a distance, and you do kind of a dead reckoning fix on your course line. And then you take a second bearing to the same object. And you can see that the second bearing is rather less than 090 degrees true. What you do is you advance your first line to where you took your dead reckoning fix on your course line. And where those two lines meet, that's your running fix. And so here's how to do it, right? So you take a bearing, you plot and label your line of position. You take a second bearing, you plot and label your second, right? You calculate how far you've gone. You mark the distance on your course line. You make it a dead reckoning position. And then you draw a line parallel. And that's where you use parallel rules. You label it with the new times. And you circle it and label it. And it's called a running fix. This comes in very handy, like if you're in the Great Lakes somewhere, if you're on either one of the coasts and you have a large navigational ATON, an aid to navigation like a lighthouse or something that's well known. Okay, an estimated position. And this is the one that's not really a fix. So what you do is you take a bearing, you plot it, okay, and then you're on your course line and you plot a DR position for the time you took your bearing. And then you draw a line perpendicular between your line of position and your dead reckoning position. And I'll show you in the next slide what that is. Okay. And then that's your estimated position where your perpendicular line and your line of position meet. So it looks like this. So this guy took a fix and he's going along this course of 290 per ship's compass at a speed of 6.1. And he took a dead reckoning position at 950. He plotted a bearing to this navigational aid at 950. And you can see what he did is he drew a line straight up from his dead reckoning position to his his bearing, and that's where his estimated position is. Now, when do you use an estimated position? When you're trying to figure out set and drift, how far off your course line you actually are, how far off your intended position you actually are. Okay. Okay, doubling the angle on the bow and danger angles, part D. Now, to answer your question about GPS positions, yes, you can use GPS positions, and that's a way of taking an electronic fix. And that was covered under the ordinary piloting part 1 and part 2. In the United States, electronic positions are always marked with a triangle, and then you always label them with the source of that data. So for instance, if you're doing a GPS, you would write the time and GPS. If it's by radar, you would write the time, and then underneath it, you would write radar. Whatever that source of electronic data is, that electronic position is. Most often it would be GPS. So doubling the angle on the bow. Okay, so doubling the angle on the bow is actually a procedure where you go onto the bow of the boat and you take a bearing on an object. And in this case, it was at 45 degrees. And then later on, you take another bearing that's double your initial bearing. And you plot those two bearing lines so they intersect your course line. And the distance that you've gone on your course line is equal to the distance that you are away from the object. Now, when would you do this? One is if you want to check the speed, your actual speed over ground. The second one is if you want to know if you're coming too close to shore, especially for the people who operate on the Pacific and the Atlantic coast. Doubling the angle on the bow is used to get a range, to get a distance to see how far offshore they actually are. To be quite honest, between the time you take the first and your second bearing, this never quite comes out to be exactly the distance. And but it is a useful rough and ready tool to do two things: figure out how far you've gone and to figure out how far away you are from an object. And it works because you're basically setting up an isosceles triangle in which two of the legs of the triangle are always equal. More importantly, at least for me in the San Francisco Bay, is knowing how to set danger angles. Now, setting danger angles is when you're following a course and you don't want to run into, say, this shoal here. So you figure out what's the course that you're actually going to run into the object. And that becomes your danger angle. And you can write it on the chart like it's done here. Unfortunately, this is not quite correct. You should say not less than. But that becomes the steering direction for the helmsman. So, for instance, this guy is going on a track of, it looks like 090. And he can turn to the helmsman and go, hey, helmsman, I want you to steer 090, but not less than 074. Okay. Well, why not, sir? Because if you do, we're going to run into these shallows and it's going to be all kinds of ugly really quickly. So I need you to make sure that you steer 090 and do not steer anything closer than 074 until we're past this lighthouse over here. Okay. And I actually do this all the time in San Francisco Bay because there's all sorts of shallows and stuff that you have to stay out of. Next one, GPS navigation. So Here's the thing about GPS navigation. Everybody has a different GPS. So I can't get specific. If you have questions, I'll be glad to answer them, but I can't be specific. So for instance, the photograph here is a Garmin. It's a fairly common Garmin. I've actually used this Garmin unit on various Sea Scout vessels. There are others like Furuno and Magellan, and they all differ slightly on how you input things. So you have to be familiar with your ship's equipment. And when you're using a handheld GPS, let's say you're on a paddlecraft or you are in a small sailboat and you're using a handheld GPS, again, you have to be familiar with the equipment that is used by your vessel. So to pass this requirement, right, you have to enter 3 waypoints, 3 or more, into an electronic navigation device, i.e. a GPS or a chart plotter, and navigate your vessel to each point. You must use the GPS you use most on your vessel. And unfortunately, this is one of those requirements where you have to be able to do it underway. So you can't put it in simulator mode and go, look, because the simulator mode on most GPSs will simply follow the track line to each point until it gets to an end. You actually have to do this while it's underway. On a paddlecraft or something, you can use a small handheld GPS to accomplish the same thing. But again, I can't be really more specific than that because it depends on the GPS unit that your ship uses most. Man overboard function. Every GPS, and actually this GP33 here is the one we have on my vessel by Furuno. You have to demonstrate the use of your man overboard function. Okay, so a man overboard button creates a temporary waypoint when you hit it. And it's called the man overboard button because one of the first things you do when you do a man overboard drill, or you actually have a man overboard, and you have a GPS available, is if you hit that waypoint man overboard button, what happens is it automatically creates a waypoint and will calculate the shortest track back to that point. And that's what the MOB button does. Okay. So that theoretically you can get back to begin looking for the person or whatever you're using for a man overboard drill or an actual man overboard. You can get back to the point where that person first entered the water. Radar. And I realize that most Sea Scout vessels don't have radar. And the requirements are that you be able to discuss the advantages of radar. So my vessel happens to have a very comprehensive radar suite. We have 2 radars, one for close up and one for long distance. And I'm pretty familiar with how to use them. So with radar, if you have radar fixed to your vessel, you have a tool that is invaluable in a lot of ways, especially in restricted visibility, whether it's at night, whether it's in heavy fog, whether it's in rain, whether if you're on the East Coast and you're in snow squalls or up in the Great Lakes. Radar can really, really enhance your safety. How? It allows the radar operator to see other vessels, aids to navigation, bridges, oil platforms, land masses, any other hazards that are secured, that are obscured by those conditions which reduce your visibility. That's the main advantage to having radar. The second advantage, it allows the navigator another way to fix a position either by using ranges to an object or by using true or relative bearings to a known object using the electronic bearing line. Okay. Finally, it aids in collision avoidance because it allows the navigator to plot the course speed and closest point of approach to other vessels. How does it do that? It's very simple. On any radar screen, you're in the center, and if you have a contact to another object that's moving, you can take 6-minute intervals and plot your bearing and range to that object, and that will then give you their course and their speed, and then you can draw out their course line and see how close they're going to get to you. And this gives you a chance to then look into the future and plan if you need to take any make any course changes or speed changes to avoid a collision. It's if you have the ability to have radar, it really is a great enhancement for ship safety. So the last part. Now I'm watching time here, so I leave time for a few questions. Publications. There are several publications that you should be familiar with. So the first one is tide tables, so you don't end up like this guy here. So you have to be able to use your tide tables and be able to figure out tides for where you are and corrections. This comes in when you're anchoring. You don't want to anchor somewhere where you're in shallow water and all of a sudden all the water goes away, which is what happened to this guy here in the photograph. You can, all tide heights in the United States are given in feet, above or below mean low or low water, which is the average of the lowest water depth in an area over a 19-year period. It corresponds to the charted depth on the chart. If you're operating in shallow waters or in waters where you may be in a deep water channel and then you go anchor somewhere that's shallower, knowing that the tide range helps a great deal in figuring out how much anchor road you need to put out, whether or not you're going to be aground when you anchor, all of those things. The most current tide predictions are available at this website right here, which is from NOAA. And there are multiple printed tide and current books available. Some have some lovely charts. Others are in table form, like the example I gave you there. Currents. Currents are extremely important, especially if you're a sailor or a paddleboard or a paddlecraft person or a scuba person. Now, it can be very important if you're a power boater. Not as much, but definitely for sailing. I can tell you there have been times where I've been sailing where, because of the current, I've actually been going backwards. For scuba activities, extremely important, because if the currents are really, really strong and fast, they may overwhelm your ability to swim to where you want to go. In paddlecraft, same thing. You could be paddling your heart out and not going anywhere because of the current. So this is a chart, right? This of a graph of the currents off of Bluff Point, which is in San Francisco Bay. And you can see that it gives you the speed, and then when your ebb tide is, when your flood tide is. It doesn't give you the height of the water. This is merely a speed and time graph, okay? If you get one of those little tide and current books from a local marina, in the back, it'll give you all sorts of corrections. Most of those are a ratio that you have to multiply the predicted current speed by. Okay. And then the time corrections to the maximum ebb and the maximum flood tide and slack water will all be added to or subtracted from the time. Light lists. So light lists are a very useful book. Light lists are given out per United States region here in the United States, and they list every single aid to navigation in that region. And there's updates to that in the local notice to mariners, which I'll talk about in a minute. You can find them at navsen.uscg.gov. You can purchase printed ones. They come out yearly, they come out annually, and then they have to be updated from time to time. Quite often, I don't have a printed copy anymore. I keep a PDF copy, and about once every 2 months or so, I download the ones that I use, and then I get rid of the older versions because the PDF ones are updated by the Coast Guard depending on what date they come out, so that they're updated pretty much weekly. Now, notices to mariners. There are two, or actually three types of notices to mariners. There's what we call the broadcast notice to mariners. If you've been on a vessel, you've probably heard that, which is a broadcast of safety information from your local Coast Guard sector. The second is the local notice to mariners, right? Hang on, let me see what we got here. You have to go, if you go, I don't have a printed one in front of me, but generally they're listed by the body of water and then the name. There may be some private aids that aren't listed. Okay, because but does that help you out any, Jason? So for instance, I can go to my light list, and look up like Napa River Light, or here, I can look up, for instance, San Francisco entrance buoy number 4. And I can look it up and it'll give me the characteristics and everything else, right? Go ahead, Josh. What do you got?
No, that very good. I was just about to say, let's try to incorporate what the question is, because not everyone might see that he was asking about how do you identify the correct light list for the body of water that you're looking for.
Right. So it's usually by body of water and then the number of the aid to navigation. So then there's something called the notice to mariners, which is issued weekly, right? The local notice and the notice to mariners contain more important information like corrections to the light lists, corrections to charts, to the coast pilot, which I'll be talking about in a minute. And they also include important navigation information like if there's a bridge closure because it's repaired or they're conducting dredging somewhere. Those kinds of things are in the local notice or the notice to mariners. They'll also talk about various temporary restrictions. So for instance, if you have some kind of boat parade or something and they ask you not to transit the area, that generally will be in there. Okay, chart corrections. So when you do chart corrections, and this is part of what you have to do for ABLE, is you have to go to your local notice to mariners and you compare it to the chart you have. And the chart corrections, they have a section that says chart corrections, and it'll give you the number of the chart and it'll tell you what the correction is. It'll say move, such and such buoy from this point to this point, or whatever the correction is. Now, when you do this and you have paper charts, generally on the back of the chart, you will see that somebody has written the number of the chart, the title of the chart, the date of publication, and then it's corrected to whatever local notice to mariners number it is, and they all have a number. They're all numbered weekly. So for instance, we just started with, this would be week 1 of 2021, for instance, okay? And then you would initial it, and then it would be updated. With electronic charts, you can go to the NOAA website and download actual updated weekly electronic charts. And you have temporary changes should be noted, because sometimes you'll have this marker over here was hit by something or is extinguished or whatever, and it is being replaced, temporarily replaced by a buoy, for instance. Those should be noted, just so that you're aware. If you're out on the water, you go, oh yeah, that marker was replaced by that buoy over there, not by, so things may look slightly different. Coast pilots. And this is actually not mentioned very much in the manual, but I want to include it. Coast Pilot is an invaluable reference work. It contains a great deal of information about weather. It'll include how to get a hold of a bridge, various marina facilities in the area, a description, and often a aerial photograph of the waterway. Safety information. If you don't have one, they are available again online at the Navigation Center from the U.S. Coast Guard. You can just Google Coast Pilot for the area that you're in. But it just has a wealth of information, and I suggest you all take a look at those. It can help a great deal when planning a voyage. Yes. Well, I can tell you, I use not Open Captain, but Captain on my boat, CPN. So the question is NOAA moves away from printed materials, will the requirements move to using Open Captain? To be quite honest, the requirements, you could still print out charts. You can get print-on-demand charts. They will still keep that service going. I imagine sometime in the future, if they do go all electronic, we will have to, look at the requirements and update them to make sure that they include electronic charts and charting and correction. At this point, we're kind of in this hybrid model where if you use an electronic chart plotter, you're using electronic charts. But you should always have paper available. We have a saying on my vessel that salt water and electricity don't mix. And it's always nice to have a fallback should everything go dark. So that's the best I can give you on that one. And I hope that answers your question. Okay. So Josh, that's it. That was actually the last slide. I hope I did okay.
You did wonderful. So for those who aren't from the San Francisco Bay Area, Doug frequently helps judge some of the piloting events at some of the regattas, and is very experienced at teaching piloting and navigation. Really will appreciate his time. We do have, again, a comment, of course, paper backup is excellent. I am posting in the chat the other January webinars right now. We have one on the 14th on sailing, and that's going to be a lot of fun. It's going to be a hybrid of live and recorded on the water sailing. And Izzy, who's one of the co-hosts of the Lookouts podcast, a dynamic young woman who actually just got accepted to the Coast Guard Academy, she'll be the presenter on that. And then on January 26th, we have our Coast Guard Tech Talk for maritime safety equipment, which also should be a lot of fun.
Before we leave, Josh, can I interject one thing?
Sure.
A few years back, did course outlines, right, for both ordinary and able piloting. So I am going to put my Scout email address into the chat. If anybody would like a copy there, feel free to email me. And I will gladly get those out to them, because they go into much more detail than I was able to do in an hour, as you well know, because you have seen them both. Yeah, and they've been recently updated.
Yeah, and they're on cscout.org. We do have a question about the other webinars. Yes, both of them are listed on the Facebook fan page and also on cscout.org. We'll be doing a post for each month, since we have multiple webinars each month going forward, and there's a lot of fun stuff. In February, we have an underwater archaeologist who's one of the presenters, who drove the ROV that helped find the USS Nevada. And we'll talk about that, which is in 16,000 feet of water. So we have a lot of cool stuff set for 2021. Now, and you're very welcome. Now, we do have in chat, will ordinary sailing remain on? Yes, yes, we're not deleting anything. Go on, yes, we're not deleting any of our recorded content. We want people to be able to use this, and if it can help supplement one of their meetings, by all means, go ahead. That's why we have it on YouTube and Facebook, so folks can reuse the content, because this is a complicated time. You know, everyone's working very hard at how do we deliver quality program to all of our scouts. And part of the reason why we're doing this is to help you, so people can have program that can be used for a meeting. So, because everyone's scrambling with how do we come up with new and unique activities where scouts can learn for when we can get back on the water, because not everyone can get on the water right now. So do you have any other questions on piloting or what we have planned coming up for the rest of January? And it's okay to email. So I'll put in my email as well. So I do have several Scout emails, but this is one of them. And so again, if you need some help, please let us know. And of course, just want to thank everyone, you know, for all the volunteers who are watching tonight. You work extremely hard, providing hope and opportunity for youth. Thank you.
And thank you, Josh, for allowing me to do this, and because you and I both have a love of this subject, and it was good to share some of my expertise for some of the other adult volunteers who may need a little boost.
And Doug, you're one of the best when it comes to this. Doug's a teacher professionally, and it just rocks at navigation, and is a proven track record of navigating to get places. So, so again, there's lots of fun content. We're going to do our best to deliver quality program to help everybody. But if you got a request, let us know. And we're trying to be as creative, and presentations going to range from youth to adults to Coast Guard auxiliary to Coast Guard active duty to outside professionals and college professors. So we're really trying to branch out and provide more information and just have it be fun and useful. Because we have a couple more months of this before everyone can get the vaccine and we can safely have in-person activities. So thank you all. And if you are meeting, check out the BSA restart checklist, because there's lots of active units right now that are doing socially distanced meetings. But keep up the great work. And if you need help, let us know. We didn't expect to have a heavy webinar campaign on advancement, but we are, because this is what we need for 2021. So everyone, thank you, fair winds, and have a great evening. Take care now.
Good night.
Take care. You are all very welcome.